Good day everybody, this is the proof of the theorem that I've used in the previous video lesson. A subscriber has requested the proof, so I'm giving the proof in this lesson. So foremost we need a circle, and this is going to be the diameter. So the diameter is drawn. Now from the point A there is a hit on the side, or I should say on the circumference of the circle. So I need to draw that hit. So from A there is a hit, so I'm going to take this point as C. Okay. Now from C there is a tangent. Okay, there is a tangent at C, so we have to draw the tangent. Let me draw the tangent. Okay. Now this tangent is intersecting with the extended line that is actually the diameter of the circle AB. Right? So there is an intersection at this particular point. There is a tangent here, and let me take this as D. Now there is a chord connecting C with B. Now according to the theorem, BC is equal to BD. This is a very important theorem. Now this angle is given to be as 30 degrees, and as I mentioned to you, this is the center. Now this is the proof. The proof is as follows. Okay, foremost what I wish to do is I would like to apply the alternate segment theorem. Now by alternate segment theorem we know that this is 30 degree. So BCD, this is going to be 30 degree. Angle at BCD is equal to 30 degrees. This is the first observation. Right? Now we draw a line from O is the center, to C, where there is a tangent. Okay, so we connect this point. By tangent theorem, what do we know? OCD, the angle at C, or I would say by tangent theorem, OCD is equal to 90 degrees, right? Because if you draw a line from the center to the tangent, it would make an angle of 90 degrees. I'm not drawing it here, it is observed, right? So I mentioned it here. Okay, so I have a 90 degree here. Now clearly DOC and BOC are going to be equal, right? So if they are equal, what is it? Now to get the angle at BOC, we are going to use the angle made by the, or I should say, the central angle theorem, right? Now you see this arc BC, it subtends an angle at O and it subtends an angle at A, right? We observe that arc BC subtends an angle at O and an angle at A. You clearly see that. You see that? Now there is a theorem. We know that according to the central angle theorem, the same arc is responsible in subtending these two. So this would mean angle BOC is equal to twice the angle. So this is BAC, right? What is BAC? BAC is what? Is 30 degrees. So it's 2 times of 30 degrees, which is equal to 60 degrees. So this means BOC is 60 degrees. So this is a second observation. First up, in fact, it's the, we have made 3 observations. So we got this angle, we got this angle, we got this angle. Well, of course, this angle has been obtained from the data. It means, when I say data, of course we have used alternate segment theorem information. So all of these things I've got. Now consider triangle DOC, or consider triangle, you can name it whichever way you want, right? Either you can name it as DCD or DOC, up to you. So what I'm going to do is, I'm going to consider triangle, consider, or OCD, consider triangle OCD. Now why did I say consider triangle OCD? Because there is a right triangle here, right? Let me draw that. There's a right triangle here. From the law of triangles, what do we know? Angle at O plus angle at C plus angle at D should be equal to 180 degrees. Angle at C is 90 degrees. Angle at O, just now we got it, BOC, angle at O is 60 degrees. So angle at D, we need to find out. So 90 and 60, 150. So 180 minus 150, that is equal to 30 degrees. So angle at D is 30, right? Now, so this would mean the angle obtained, or I can say that BDC is 30. So let me mention that this is 30 degrees. Angle at D is 30 degrees. So you can either state it as this means angle BDC is equal to 30 degrees, or you can simply have it as 30 degrees. Okay, fine. Now go to step number 1. But we know that, let me write that down, but we know that, what do we know? BCD is equal to 30 degrees, and now we have found BDC is 30 degrees. So this is 30, this is already found to be as 30, and this means BD and BC are making the same base angle, right? Base angles. So what does this mean? This means that they are equal. This means BC is equal to BD, hence proved, right? Hence the statement BC is equal to BD is proved, because only if the sides are equal they will have the same base angle. We are talking about an isosceles triangle. And if you have any questions, please post them in the comment section. Thank you everybody. Please like, share and subscribe the video and keep us encouraged. Thank you.